Hi, this is a lesson for Year 10 Higher Mathematicians. It's week 10, the topic is Pythagoras' theorem, and this is lesson 29, Pythagoras' theorem, problems 2. Now, I'm not going to revise Pythagoras' theorem here, how to find the hypotenuse in one of the shorter sides. This is a lesson just looking at a very particular type of problem that often occurs with Pythagoras' theorem. And this is where we're looking to form and solve an equation that arises from a right angle triangle. So this example then, we're looking to find x, and we're asked to form an equation in x, expand the brackets and simplify the equation. Well, hopefully we recognise that this is a right angle triangle and that these sides are going to be linked together by Pythagoras' theorem. So if we do that, we can form very quickly the following equation. X plus 5 squared must be equal to x minus 1 squared plus x squared. We now need to expand those brackets, and once I've expanded these, I'm going to go straight to the simplified version of each expanding bracket. So I know that x plus 5 squared is going to give me x squared. It's going to give me a 5x and a 5x, therefore 10x altogether, and also 25 there. And similarly here, x minus 1 squared is going to give me x squared. It's going to give me minus x and minus x, therefore minus 2x. And minus 1 squared, remember, is going to give me positive 1, plus the x squared that I've already got on the end here. And simplifying that is going to give me, on this side of the equal sign, x squared plus x squared equals 2x squared minus 2x plus 1. That is as simple as I can get that side, remember, because I can only collect together like terms. And similarly, over here, I've got x squared plus 10x plus 25. That is as simple as that left-hand side will get. Now, what do I do next? Well, hopefully, at this stage, you're going to recognise that what we have here are sort of two quadratic expressions. And if we are going to rearrange these to leave a single quadratic, then it's got to be equal to 0 if we're going to be able to solve it. All the techniques we have at this stage for solving quadratic equations rely on the equation being made equal to 0. So what I'm going to do is I'm going to take away x squared from both sides of the equation here, and that's going to leave me with x squared on the right hand side. I'm going to take away 10x from both sides of the equation, which is going to leave me with 12x on the right hand side, and I'm going to take away 25 from both sides, leaving me with minus 24 on the right hand side. And because I've taken away everything from the left hand side, that means it should be 0. Now the question is, how are we now going to solve this quadratic equation? And there are a few different techniques that we have available. We've got trial and improvement, completing the square, quadratic formula, factorization. We've got the graphical solution, iteration. There are a few others, okay, if you're you might be aware of them. But the one that I'm going to use today is the completing the square. Okay, so completing the square, the technique is we want to put this into a bracket that looks something like that. Well, I know that in that bracket I need to half the coefficient in front of the x, okay, which gives me minus 6. And if I expand these brackets now, x minus 6 squared, that gives me the x squared, which I've got already. It gives me minus 6x, which gives me minus 12x, which I have got. All right, but that also gives me a plus 36, okay, which I don't want, therefore I need to take that away. And I've still got my minus 24 from before. Simplifying that gives me 0 is equal to x minus 6 squared, and minus 36 minus 24 gives me minus 60. So I've now written this in completed square form. Having written in completed square form, I am now able to solve the quadratic equation just simply by rearranging. So x minus 6 squared is going to be equal to 60. X minus 6 is equal to the square root of 60. However, remember that a square root can have a positive or negative solution. So this could be plus root 60 or minus root 60. We'll have a look at that again in a minute. And x is therefore be equal to 6 plus or minus the square root of 60. If I was to type those into my calculator, the two I want to pop in are going to be x is equal to 6 plus root 60, or x is 6 minus root 60. Giving me either x is equal to 13.75 or x is equal to 1.75. So those are the two solutions, and as it happens we'll look at in a bit more detail. One of these solutions isn't possible. Okay, we'll have a look at why that is in a moment. All right, but x equals 1.75 is not a possible solution, which leaves just x is equal to 13.75. So that pretty much is the technique that we're going to use today. We're going to use Pythagoras' theorem to form the equation, simplify that, complete the square, then solve the equation, and that will hopefully allow us to find the length of all the missing sides. Well, let's have a look at another example. Again, form an equation in x, expand the brackets and simplify the equation. That's what we need to do initially. So we will start out then using the same technique we've done before. We're going to say that x plus 3 squared must be equal to x minus 2 all squared, add x squared. Multiplying out the brackets, and again I'm going to go straight to the simplified form. Well, that's going to x plus 3 squared is going to give me x squared, plus 3x means it's going to be plus 6x, and 3 squared is 9. X squared minus 2x is going to give me minus 4x, plus 4 plus x squared. And when we simplify, remember that we have to collect the like terms together. The like terms in this particular case are the x squared. So 2x squared minus 4x plus 4. And this is as simple as this side will go. Now, I'm being asked to complete the square, but I know that I need to rearrange this to get all the terms onto the same side, make it equal to 0, and that will allow me then to complete the square. So I'm going to take away x squared from both sides, leaving me with x squared on the right hand side. I'm going to take away 6x from both sides, leaving me with 10x, take away 10x, sorry, on the right hand side. And I'm going to take away 9 from both sides, leaving me with minus 5. And because I've taken everything on the left hand side away, there is nothing left there, 0. I'm going to complete the square. So what goes in the brackets? Remember, we halve the coefficient of the x term, minus 5. Now I know that x minus 5 squared is going to give me x squared, which I've got. It's going to give me minus 5x and minus 5x, which is minus 10x, which is what we've got. However, it's also going to give me plus 25, which I do not want. So I'm going to have to take away the 25 there. And I've also got the minus 5 from before, which simplifying gives me 0 is equal to x minus 5 squared minus 30. Okay, so I've transferred that answer down here, and I'm being asked to solve the equation now. So if I rearrange this then, that's going to give me x minus 5 squared is equal to 30. X minus 5 is equal to the square root of 30. Remembering that square root will generate two solutions, a positive one and a negative one. And x must be equal to 5 plus or minus the square root of 30. Now if I type those into my calculator then, I'm either going to have x is equal to 5 plus root 30, or x is equal to 5 minus root 30. That puts x is equal to 10.48, or x is equal to negative 0.48 here. Okay, and those are centimetres. Now we're being asked to find the length of all the sides. So in other words, just turning back and looking at the example, the sides are x plus 3, x minus 2, and x. So we've got x plus 3, x minus 2, and x. Now it should be clear fairly quickly why this answer here now cannot be a solution. Because if we have x is equal to negative 0.48, that means that the side length of one of the triangles is going to be negative 0.48. That means nothing because the measurement is a negative. We have to disregard that particular measurement. What it does mean is that we can, if x is equal to 10.48, it does generate proper solutions for the other side lengths. So 10.48, x minus 2 means that this one is going to be 8.48, and x plus 3 means that the hypotenuse is going to be equal to 13.48. Remember, all these answers from here are to 2 decimal places.